Welcome everyone to the live interactive session for the course Natural Gas Engineering. Today we are going to discuss some sample problems which are based on assignment number 8. My name is Ananya Mandal and I am TA for this course. So let's start with the first question where they are asking to match the following. Where in the left side they have given different gases such as cold bed methane, gas hydrates, oil shell, and tight gas. Whereas on the right side, they gave some of the properties of these resources, such as CH4.7H2O, kerosene, impermeable limestone rock, and thermogenic process. So we have to match the natural gas uh, type to one of the properties. So first, let's talk about the cold bed methane. Cold bed methane can be of two types, that is thermogenic cold bed methane and biogenic cold bed methane. So this thermogenic and biogenic depends on the process that is required for this cold bed methane. So since there is a thermogenic cold bed methane, so uh, that can be found taken out by using the thermogenic process. So first one will connect to the match to the fourth option. Next is gas hydrates. So gas hydrates for different gases, gas hydrates means it has some gas and some amount of H2O. So different gases like methane, ethane, propane and CO2, they attach with hydrogen, attach with H2O in different proportion. So methane, it attaches with 7 H2O. Ethane attaches with 8 H2O. Propane with 18 H2O and CO2 with 7 H2O. So from here you can see all of this are some type of gas hydrates. So CH4.7H2O is a type of gas hydrate. So we will match second option with the first one. Now oil shell. Oil shell are organic matter also known as kerosene. It has 10 to 12% kerosene and bitumen as 1%. So oil shell has these two things. One is an organic matter. These two organic matters, kerosene which is 10 to 12% and bitumen that is 1%. It's a mineral matrix and small amount of free and bound water is also present. From that, you can match the third option of oil shell with kerosene as it has 10 to 12% of kerosene in it. And finally, tight gas. The tight gas, as you can see here, there is different definitions of what type of rocks these all gases are found. So tight gas, they are found in relatively impermeable rock, limestone or sandstone with diameter less than 1 md. Shell gas is a gas trapped in fine grained sedimentary rock shell. Coal bed methane is a gas trapped in coal seams adsorbed in the solid matrix of the coal, and gas hydrate and crystalline cage-like structures, water molecules stabilized by small gas molecules. So, from all these uh, properties of the places where we can find these gases, we can see for tight gas, we require a relatively impermeable rock such as limestone or sandstone. So we can match option 4 with number 3, that is impermeable limestone. From these matches, we can see option B is the correct option. Next question is to identify the incorrect statement. So the statements are option A. Gas hydrates are the most abundant conventional reserves available to produce natural gas. Option B. Unlocking the domestic unconventional gas potential would help India meet its growing energy demand. Option C. Presence of highly soluble gases in water such as H2S and CO2 form the natural gas hydrate easily. And option D. Numerous disasters in underground coal mines occur due to methane explosion. So we have to find which of these statements is incorrect. So let's discuss about all of these statements, and from that we will be able to understand which of them is correct or incorrect. So first statement is about gas hydrate. So gas hydrates are crystalline cage-like structures. The cage is water molecules stabilized by small gas known as guest molecules trapped in the cavities under high pressure and low temperature conditions. Most commonly, the small gas molecules are light hydrocarbons and other gases that may be present, that is H2S, CO2 and 2. So you can see option C, they are talking about the presence of highly soluble gases in water such as H2S or CO2 form the natural gas hydrate easily. So here also you can see the statement that most commonly the small gas molecules are light hydrocarbons and other gases that may be present such as H2S, CO2 and N2. So these H2S and CO2 and N2 are they are present in this water also. So this statement is correct one. Next is about unlocking the domestic unconventional gas potential could help India meet its growing energy demand. So this was one of the statements explained and discussed in class, that unlocking the domestic unconventional gas potential could help India meet its growing energy demand. However, it needs to be developed profitably and in an environment acceptably manner. So this statement is also correct. The numerous disasters, option D, the numerous disasters in underground coal mines occur due to methane explosion. So, when we studied about cold bed methane, which are the gas trapped in coal seams absorbed in the solid matrix of the coal. So, the points that we discussed are the knowledge of methane occurring in coal beds is as old as coal mining. Numerous disasters in underground coal mines occur due to methane explosion. Conventional method was ventilation of mines, pure methane and more energy, and large quantity of methane 3 times at same peak and depth. So here you can see the statement that numerous disasters in underground coal mines occur due to methane explosion. So option D is the correct one. Now let's go to the first statement, that gas hydrates are the most abundant conventional reserves available to produce natural gas. So you can see unconventional natural gases has geological setting and rock type rather than that of gas itself. And these are the different unconventional natural gases. That is shell gas, tight gas, gas hydrates, and cold bed methane. And there are others. So all of them comes under the name unconventional natural gas. But here they said that gas hydrates are the most abundant conventional reserves available to produce natural gas. So that's why this statement is incorrect, because gas hydrate is the unconventional natural gas. Hence, the correct option for this question is option A. The next question, question number 3, is that which of the following gas forms structure 2 gas hydrates? Options are A, methane, option B, ethane, option C, propane, and option D, hydrogen sulfide. So there are two types of crystalline structures which have been proposed for gas hydrates, structure 1 and structure 2. Structure 1 is it is formed by smaller molecules such as methane, ethane, and hydrogen sulfide from a body-centered cubic lattice. Whereas structure 2, it is diamond lattice formed by larger molecules such as propane and isobutane. Gas mixtures form both structure 1 and structure 2 type hydrates. So here they are talking about structure 2 gas hydrates. So structure 2, it is a diamond lattice formed by larger molecules such as propane and isobutane. So from the options you can see methane, ethane and hydrogen sulfide, they form structure 1, whereas propane forms structure 2. That is the correct answer. Next question, question number 4 is that select the correct statements regarding the mechanism of gas flow in a cold bed and arrange it in the order of gas flow from the micropore. So different steps have been explained and you have to choose the step which is the correct order of mechanism of gas flow in a cold bed and we have to arrange in order of gas flow from the micropore. So first option, the Darcy flow through fracture and clips to the wellbore. Option 2, diffusion of the gas from the cold surface inside the micropores. Option 3, Darcy flow through the micropores to the wellbore. Option 4, adsorption of gas from fracture and clips to the micropore. Option 5, desorption of gas from cold surface inside the micropores. And finally, option 6, the diffusion of gas through the micropore. So we have to arrange them in the proper sequence. So for that, option A is that zero point 0.5, then 6, then 1. Option B, zero point 0.4, then 2, then 3. Option C, zero point 0.2, 4, and 6. And finally, option D, that 0 0.3, 1, and 2. So the CVT extraction technology is a mechanism of gas flow and diffusion of gas molecules inside micropores. So it has these three steps in this order. First step is that desorption of the gas from the pore surface inside the micropores. Second step, diffusion of the gas through the micropores. And third step is Darcy flow through the fracture and flows through the wellbore. So this is the uh, correct sequence in it. The gas flow occurs. So first is desorption of gas from the pore surface inside the micropore. So which of the option it is? It is option 5. Next is diffusion of gas through micropore, which is option 6. Finally, the Darcy flow through the fracture and close to the wellbore. So Darcy flow, there are two of them, either through fracture and fuse to wellbore or through micropores to the wellbore. The correct sequence, correct option is first one, Darcy flow through fracture and fuse to the wellbore. So when we will arrange this, we will get option A. That is 0 0.5, then 6, then 1. So that is the correct sequence, correct answer. Next question is question number 5, that what are the factors affecting methane content in the coal bed? Options are A, porosity and adsorption capacity. Option B, fracture permeability and coal density. Option C, both A and B, or option D, none of the above. So it has been taught in the class that the factors affecting the methane content in coal bed are the porosity, adsorption capacity, fracture permeability, and other factors such as coal density, pressure difference, and thickness of formation. So from that you can see both option A and B, the porosity, adsorption capacity, fracture permeable, and coal density. All of these options affect the methane content in the coal bed. So option C is the correct option, that both A and B are factors affecting the methane content in coal bed. Next question, question number 6, is to identify the type of pore in the natural gas reservoir that contains shale gas. Options are A, large, well-connected pores. Option B, small, poorly connected pores. Option C, very small, hardly connected pores. And option D, none of the above. So the different types of gases, such as conventional, tight gas, and shale gas. So they have discussed what type of pores are uh, pores are there in which this kind of gases are found. So, for conventional gas, large and well-connected pores are identified where it contains that conventional gas. Tight gas are found in small and poorly connected pores, and shale gas is found in very small, hardly connected pores. So, from these, you can find out, as they have asked in the question for shale gas, so they need very small and hardly connected pores. So option C is the correct answer. Next question, question number 7. That identify the natural gas produced from reservoir rocks with such low permeability as limestone or sandstone. So options are A, tight gas, option B, shale gas, option C, coal bed methane, and option D, gas hydrates. So we have to identify which of this natural gas is produced from reservoir rocks with low permeability as limestone or sandstone. So before also we discussed that for different gases, the different kind of rock formation is given. That is for tight gas, it is relatively impermeable rock, limestone or sandstone. For shale gas, it is gas trapped in fine grained sedimentary rock. Coal bed methane is gas trapped in coal seams absorbed in solid matrix of the coal. And gas hydrate are found in crystalline case-like structure, water molecules stabilized by small gas molecules. So from that we can see we have to identify the natural gas produced from reservoir rock with low permeability as limestone or sandstone. So that is the statement for tight gas. So option A is the correct option. Next question is question number 8. To identify the incorrect statement, options are A. Natural gas hydrates as crystalline cage-like structures in which water molecules are stabilized by trapped small gas molecules. Option B. Natural gas hydrates are formed when natural gas components enter the water lattice, causing the water to solidify at temperatures considerably lower than the freezing point of water. Option C. Natural gas hydrate formation can be prevented by keeping the temperature of the natural gas system above the hydrate temperature. And option D. The structure 1 type of hydrates are formed by smaller molecules and structure 2 type of hydrates are formed by larger molecules. So all these statements are they are talking about the natural gas hydrates. So we will see from the theory of natural gas hydrate. So gas hydrates are crystalline cage-like structure. The cage is water molecules stabilized by small gas known as gas molecules trapped in the cavities under high pressure and low temperature conditions. Most commonly, the small gas molecules are light hydrocarbons, methane, ethane, propane, and other gases that may be present H2S, CO2, and N2. Two types of crystalline structures have been proposed for gas hydrates. Structure one is that formed by smaller molecules such as methane, ethane, and hydrogen sulfide from a body-centered cubic lattice. And structure two, it is diamond lattice formed by larger molecules such as propane and isobutane. The gas mixtures form both structure one and structure two type hydrates. Now, natural gas hydrates are formed when natural gas components, notably methane, ethane, propane, isobutane, butane, hydrogen sulfide, carbon dioxide, and nitrogen, enter the water lattice and occupy the vacant lattice positions, causing the water to solidify at temperatures considerably higher than the freezing point of water. Now, for this theory of gas hydrates, we have to find out which of the statements is incorrect one. So, first one, they are talking that natural gas hydrates are crystalline cage-like structure in which water molecules stabilized by trapped small gas molecules. That you can see is what is written when defining the gas hydrates. So, option A is the correct one. Option 2, that natural gas hydrates are formed when natural gas components enter water lattice, causing the water to solidify at temperature considerably lower than freezing point of water. So here you can see it has been highlighted that it solidifies at temperatures considerably higher than the freezing point of water. But here in the option they are saying lower than the freezing point. So that is not correct. So option B is the incorrect one. Let's see option C and D also. So natural gas hydrate formation can be prevented by keeping the temperature of natural gas system above the hydrate temperature, which is correct, as if the temperature is higher than the hydrate temperature, then the water molecules will not solidify and it will not form the gas hydrates. And structure one type of hydrates are formed by small molecules and two type by larger molecules, which is been also explained while defining the different structures for hydrates, gas hydrates. So here option B is our incorrect statement. So we have to choose option B. Next question, question number 9, is that in the mechanism of gas flow in coal bed, Darcy flow occurs through options are A, the micropore to the wellbore, option B, the coal surface to the wellbore, option C, the fractures and clefts to the wellbore, or option D, the coal surface to the micropore. So during the discussion of the steps followed for diffusion of gas molecules into the micropores, you can see the third step where they talk about Darcy flow taking place through the fracture and cliffs to the wellbore. So from that statement, we can find out the correct answer for this question. So the options: micropore to wellbore, pole surface to wellbore, fracture and fuse to wellbore, or pole surface to micropore. So you can see the Darcy flow through the fracture and fuse through the wellbore. So option C is the correct answer. The last question is again a match the following, where you have to match different types of gases: conventional gas, tight gas, and shell gas, to the condition of the rocks and pores that they are found in. So first one is large and well connected pores, second is small poorly connected pores, and third very small hardly connected pore. So we have to match these. Since we already discussed for these gases what are the different types of pores required, available, and which these gases are found. So for conventional gas it is large and well connected pores. So that will be first with the first option. For tight gas, it is small and poorly connected pores. So second with the second option. And shell gas, it is very small and hardly connected pore. Third with the third option. So from that we can see option A is the correct answer. Thank you.